Thank you to the NASA folks who are here. And I am delighted and thrilled to have and to announce the administrator of NASA who made his way to Pittsburgh. Thank you to Crew 4 for not launching today. And he's in a conversation with the congressman, so I can talk for a little bit more if needed. NASA Administrator, we are delighted to have you here. Thank you for coming. I love your jacket, and welcome to the Keystone region.
Well, guys, this is an exciting time to be interested in space. Right off the bat, we're going back to the moon, and then we're going to Mars. Now, we're already on Mars and have been since the 1970s with Mars observers and Mars rovers, and now we have a Mars rover that's the size of a small SUV, Perseverance, that's going around, and it's drilling holes, and it's putting those cores in titanium tubes, and it's going to collect about 40 of them, and it's going to put some here on the surface. It's going to keep some internal, and then we're sending another Mars lander, and it's going to either pick up those core samples or have it delivered directly from the rover itself, and those samples are going to come back and into our laboratories, and then we're going to analyze those and see, was there any kind of sign of life? And if so, what happened? Was it developed? Was it civilized? And what happened? That's just one mission that we have going on in NASA. Since half a century ago, we landed on the moon with humans. We're going back, and the beginning of that starts this summer, the launch of the largest, most powerful rocket ever, the Space Launch System, with its spacecraft on the top, Orion. And this will be a test flight, uncrewed. In 2 years, the first crew that will spend 30 days in orbit around the moon. And then a year later, the first crew that will orbit in a polar orbit of the moon will rendezvous and dock with a lander, and that lander will take the first woman and the next man to the surface of the moon. Now, if that's not exciting enough, look what we just put up on Christmas morning. A telescope that, because it had to fit into the nose fairing of an Ariane 5 rocket launched at the equator on the northeast coast of South America, then once it got into the vacuum of space, it had to unfold. There had to be 244 things that worked perfectly. Otherwise, it was catastrophe, and everything worked. And that big mirror has folded out with 18 individual mirrors, now all calibrated on the target star, and it's all working. This summer, we will receive the first images of the capture of light in the infrared spectrum that has been traveling at the speed of light, 186,000 miles per second, has been traveling for 13.5 billion years. That's the light that is emitted about 200 or 300 years after the very beginning. Light that we're going to determine the first formation of the first galaxy. And now we are a galaxy, our own, the Milky Way, that has billions of stars or suns, but there are another billions of galaxies with billions of stars. And that light has been traveling for 13.5 billion years to reach us in this telescope that will bring that information to us. Now, is this exciting or what? But what you are doing is exciting, because what you're doing is you're taking us in a new era, a part of which I had the privilege of working in a bipartisan way. And by the way, Matt Cartwright is a chairman of a very powerful appropriations committee that he operates in a bipartisan way, because you really can't get anything done unless you work in a bipartisan way. And I did that 12 years ago with a senator from Texas, a Republican, with me as the chairman or the ranking member to her as the chairman. And we set NASA on a new course, and it was a dual course. There was the government course, of which I've just described to you, but there was then a commercial course. And the commercial course was the recognition that the government, NASA, can't do it all, even though we've obviously always operated through companies that have made this program so successful, and 50 years ago, the Apollo program so successful. But now, it's not the Apollo generation, it's the Artemis generation. And that's what you all are going to be the beneficiaries of. A government public-private partnership with commercial industry, and thus in low Earth orbit, we have this magnificent thing called the International Space Station, directly participated in by 16 countries, built together with the Japanese, the Europeans, the Russians, and the Americans. All the trouble that we're having with the president of Russia right now, in the slaughter that we're seeing daily on our TV screens, that's not evident in our professional relationship between cosmonauts and astronauts. And by the way, this goes back years. In the midst of the Cold War with the Soviet Union in 1975, an American spacecraft, Apollo, and a Soviet spacecraft, Soyuz, rendezvoused and docked in space, and the crews lived together. Those crews, led by two generals, General Tom Stafford, Apollo 10 astronaut, Gemini astronaut, and General Alexei Leonov. And the result of that friendship lasted over the years, so much so that Alexei arranged for Tom to adopt two Russian boys who are now out of college. And when Alexei died 2 years ago, who gave the eulogy at the funeral in Moscow? Tom Stafford. That's the relationship that you can have in space. It's a relationship when you look out the window of a spacecraft back at Earth, you don't see political divisions. You don't see religious divisions. You don't see racial divisions. What you see is, you see that we're all in this together. That's the promise of the future despite what we see happening on the face of the earth right now. And that's the promise of the Artemis generation. For you specifically in this 3-state area, 13,000 jobs are directly as a result of the civilian space program. Billions of dollars, and it's only going to get bigger. And it's going to get bigger because this public-private partnership. We, NASA, want to get out of low Earth orbit. Our space station is getting old. We're going to keep it going for another 8 years, and then we're going to deorbit this International Space Station that in this Heinz Field, the Steelers, from one goalpost to another, that's how big the space station is up there. And it's going to be replaced with commercial space stations. And we, NASA, are going to lease space to do our research and to send our astronauts for training before we get further on out into the cosmos. And that's where we're going, out into the cosmos. One final thing. Most people are fascinated about us trying to find all these objects out there that might threaten planet Earth. We know that the dinosaurs were eliminated by an asteroid that was about 6 miles wide and hit the Yucatan Peninsula. And that eliminated all of that life, the dinosaurs. Well, we're constantly looking. We're putting up a spacecraft later this year that's going to look to see if we see any of those that are really threatening us. And you know what we did last fall? We sent a mission out called DART. It's going to rendezvous with an asteroid. It's going to ram it at 15,000 miles an hour, and then our telescopes are going to look to see if it slightly moved it in its orbit around another asteroid, and if so, then if we detect a killer asteroid headed to Earth, we've got a chance, if we can get it far enough out, to hit it and slightly move that trajectory so that by the time it got to Earth, it would miss us. Is this an exciting time or what? And you all are a part of it. And I can tell you, thank goodness for Pennsylvania and Matt Cartwright, that he's going to give us all the money in the world that we need. So thank you for what you're doing. Thank you for your interest. And I'll tell you one space story as I exit, because you only allocated me 10 minutes. So when you get into zero G, your first instinct is, I want to get from here to there, is to do this. And of course, that doesn't help you at all. So you quickly have to reprogram your brain so that you either have to push yourself in that direction or pull yourself. In other words, if you went into a spin, a somersault, and you didn't have anything to grab onto, you'd just continue. You wouldn't stop. Space is a unique environment. It gives us a near zero gravity environment in which to do things. On the International Space Station, we're researching new pharmaceuticals. We're doing new medical research. When I flew 36 years ago, my experiment was a cancer research experiment sponsored by a medical school at the University of Alabama at Birmingham. That kind of research continues today. it's an exciting time. No telling what the properties of space are going to bring us. Look how much we've learned about who we are and what we are and where we came from just by our exploration of space. And by these telescopes, we're going to learn more. This is an exciting time. Onward and upward.